So I'm Rebecca Fiebrink. I'm going to talk to you a bit about the work that I do around using machine learning as a creative tool. But in some senses, this is quite different from the creative uses of machine learning that you saw in yesterday's amazing talks. Specifically, I'm going to be talking about using machine learning to make sense of sensor data and to make sense of small data and to make interactive stuff like musical instruments or robot controllers or, I don't know, other weird things that I will show you. So many of you, if you've done anything with physical computing, with microcontrollers, if you've built systems with Connect or Wiimote, or you've done interactions with the sensors in smartphones, you know that this is really fun. There's a lot of stuff you can do. This is ripe for creative exploitation by professional artists, by kids, by hackers and makers. And it's really exciting. It's only getting better and easier and cheaper to work with this stuff. If you've built anything with this stuff, you're pretty familiar with the basic process, right? You've got to get that sensor data into a computer or maybe into a microprocessor of some sort, sense what's happening in the world, what a person is doing, and then interpret that. Maybe say, okay, this person's hand is doing a particular action above a leap motion, and therefore the response is that this virtual object should be picked up, or your computer music synthesis should make this particular sound. And with these sensors, actually acquiring this data is pretty easy, getting easier. If you're a programmer in processing or MaxMSP or any number of environments for doing cool interactive real-time stuff, this piece of saying, okay, I know what I want the computer to do, now I'm going to give it the program code to do that, that's increasingly easy. However, this interpretation step where you say, okay, this is what my data is coming in, and based on that, what is it that I want the computer to do? That part is often difficult or annoying at best. And the standard method that we have for doing this is computer programming. This is some code that looks at some sensor values, I forget which ones, and then does a bunch of if-then-else statements and a bunch of thresholds. And a lot of you have written this code. It's doable sometimes, but even if you're an expert programmer, there are challenges. Often you have to do some signal processing to massage your data a bit. Often you're dealing with high dimensions of data from lots of sensors, or you're dealing with noisy data. And debugging this can be really annoying. It's certainly not a process in which you're going to be surprised by serendipitous bugs in your code, right? That's not the norm in this kind of programming. Usually you're sitting there just saying, come on, just give me the right threshold. So in the work that I do, I use machine learning to get rid of this process. And today I'm going to give you some demos of how I use machine learning to do this, and then I'm going to step back and talk about how to understand machine learning as a creative tool, why it's useful as a creative tool in this kind of context. So my solution, more specifically, is to build interactions, relationships between sensed values and computer responses using examples. So I'm going to be using, in this talk, a very specific type of machine learning called supervised learning, where you, as the builder of a new musical instrument or a new game controller, are going to show it examples of, hey, here's a thing that I could do. Maybe this is a closed fist. And when I do this, make this sound, or make my avatar jump, or so on. And when I do this other thing, make this other sound, or make my avatar throw a fireball, or whatever. Right? So that's easy for me to do. Right? It's easy for me to explain to you how I want that controller to work. And it's pretty easy for people to explain to a computer as well. Another variation on this is, instead of saying, hey, give me labels of stuff that I'm doing, a variation might be to use regression, where you've got motion that might be changing smoothly over time. Maybe when I move my hand like this, I want the virtual controls of my synthesizer to move up and down like that. Lots of people doing this kind of work in the NIME community, which is my home community. And to do either of these things, to do classification or regression, to do gesture categorization or continuous control, we're going to use supervised learning. For those of you who aren't clear on your different branches and sub-branches of machine learning, supervised learning basically looks like this. We've got an algorithm. Our algorithm is a tool for building a model. And our model is just a function, right? This might look exactly like what you would write in programming code if you were writing this from scratch. And this function can see new inputs, maybe new hand positions in front of the camera, and compute new outputs. But instead of requiring someone to sit down and write this model function as a programmer, we can get the algorithm to do it for us. And in this case, we might give our algorithm a set of examples of hand positions and examples of labels for those hand positions. And then if everything goes well, we've given it enough examples, we've chosen a good algorithm, it'll give us a model that's capable of seeing new hand positions, and it'll make intelligent, or at least appropriate, outputs. Okay, so that's the basic flow of things. I'm going to show you a bunch of demos of this. All right. Now, the software that I'm going to show you is called the Wekinator. I created the first version of this in 2009 as part of my PhD work, and it allows you to apply supervised learning to all sorts of real-time applications. It also is quite different from a lot of the other applications of machine learning you've seen yesterday or in the workshops today, in that it doesn't assume that you have access to a big data set. Right? So imagine I want to make this sort of hand position controller. I am not going to be able to go on the internet and download the canonical ground truth data set of hand positions in front of webcams in this room with me and this background with the sliding conditions and so on, right? But I don't need to. I can just give some examples right here, give training data that communicates my intentions at this moment in time in this room, and get started. So the first thing Wekinator allows you to do is create your training examples from scratch. And then you give those to an algorithm. The algorithm builds you a model, and you can try it out. Right? So we're not going to take this model and say, oh, we're going to compute all these statistics on it and find out if it's good. Right? Because what does that mean if you have a model that's 90% good? Like, does that really mean it's 90%? Is it an A? I don't know. But what you can do is give it more hand positions and say, all right, I'm going to move my hand around and see what it does. And if I like it, great. I'm going to save that and use it exactly the same as if I had written this as a program in code. But if I don't like it, if it's making a mistake somewhere, or if I want to make it more complicated, I can go back and give it more examples. Right? And so I can keep doing this process. And this process here, some of you may have heard the term. If you haven't, today is your lucky day. This is sometimes called interactive machine learning. So this process of putting the human in the loop, where it's not that I've got a data set and I'm trying to choose different algorithms to model this data the best. I'm actually changing the data very actively, very interactively in this quick feedback loop in order to shape this model and guide it in a productive direction. So, and as you saw flash up on the screen here, in the demos I'm going to show you, Wekinator is going to receive data from the world, from some sort of sensor, and it's going to send data out back into the world, maybe to MaxMSP or Open Frameworks or something, using this protocol called Open Sound Control. So this means you can plug in pretty much any kind of sensors, plug in your Twitter feed, plug in who knows what, translate it into an Open Sound Control message and send it to machine learning. And then on the output side, you can plug it into your favorite software for doing real-time stuff. So let's do a couple demos. The first demo I'm going to show you is classification, where we're going to use Wekinator to do some labeling. And I'm going to use what I often call the world's worst computer vision system as my starting point. Oops, not that one, this one. What I'm going to do here is get the data from my webcam and just downsample it into a 10 by 10 grid. There's me, hi, right? This is a horrible computer vision system. It's changing a bit when I move, but I wouldn't want to have to write the code to make sense of this and say something useful about it, right? But lots of the data we work with in the real world is kind of like this. We've got lots of dimensions, there's lots of noise, it's kind of hard to figure out what's going on, but we're going to use machine learning to hopefully do something useful. So I'm going to load up Wekinator and tell it to listen for these 100 values, 100 brightness values. I'm even throwing away the color. And build me a classifier to control that drum machine you heard when we were sound checking. And so I'm going to make my data set from scratch, because I don't have an off-the-shelf data set from this feature extractor in this room. And I'm going to start by saying, all right, when the computer sees me right here, make this sound. So I'm going to start recording some examples. And here you see I've got 17 examples, 17 snapshots of me in front of the computer, captured and matched with this sound. And I'm going to do it for another sound. And I'm going to record some examples when I'm not standing in front of the computer. Okay, so I've got 35 training examples. This is a tiny training set for lots of applications, but hopefully it'll work. I'm going to train, build a model, and run it. All right. Pretty good. It's making a few mistakes right here, so I can give it some more examples. So I'm going to say, it doesn't matter if I'm leaning a little bit to the left or right. That is all still me. Please still make this sound. Retrain, rerun. All right, now it's more robust. And I can make it more interesting, say, all right, I'm happy with it so far. How about my hand? So I'm going to show it my hand. Retrain, run. Right? So there's our classifier in 60 seconds or less demo. Right? Okay. So that's useful for some stuff. Again, if you've got noisy sensors, if you've got high-dimensional data, often you can use machine learning to do the same kind of stuff for the same kind of reasons that people use machine learning in really serious applications, where you're trying to make sense of medical data or financial data or whatever. I hear people do these things. The other example I'm going to show you is a little bit more interesting in the field that I come from, which is building new musical instruments. So this drum machine, right, I could play you this same drum machine by pressing a button. It would even be a little bit more accurate. But there are things that I can't do with buttons. I can't do really continuous expressive control over lots of sound synthesis parameters. So let's build an instrument to do that. And I'm going to give you guys a choice. I've got a leap motion, and I've got this golf game controller here. Who wants to use the leap? One person. Who wants to use this thing? Everybody else. All right. So this is a PlayStation golf game controller that acts like a 6-axis joystick. I've got these 2 strings, and I'm going to get X and Y kind of rotation and string length. And I'm going to run a program that takes those 6 numbers and sends them as OSC messages. And I'm going to send that to Wekinator. So 6 values. And this time let's make some weird sounds. This is my favorite synthesis algorithm. This is called Blowtar. And Blowtar is my favorite because it has a huge sound palette. I'm going to control 9 different parameters of control here. And I'm going to start out by showing you guys some of the sounds that Blowtar can make. There we go. So there's kind of the fluty, the blow part of the sound. And then we get this like electric guitar kind of thing. That's the tar. Right. So Blowtar can make a lot of different sounds. These are just a few presets that are favorites in the space. And if I'm a composer and I want to build a musical instrument out of this where I can control these sounds and move from one sound to another over time in a musically expressive way using this controller, then essentially I have to design a pretty high-dimensional mapping function where I take 6 dimensions of input and based on those 6 numbers, compute 9 values of output to control these 9 control parameters. So that's going to be a big pain, especially if I want to have a say in the finer details of how I'm going to control it. But let's use machine learning. I'm going to tell Wekinator to listen for these 6 values and send 9 values to max. And this time we're going to use continuous regression for all of these. So I'm going to start out by finding a sound that I like. And I say that sound. And maybe I want that sound to be right here when I do this. All right, so I've got 40 snapshots of me doing this with that sound. And maybe when I pull out a little bit like that, I want it to go up in pitch. So let's just start with that. I'm going to train and run. Right, so it's learned that. I've got sort of a slide whistle thing happening. Let's make it more interesting. I really like that sound. Let's put that in my instrument somewhere else. I'm going to put that over here. initial sound. I still got some slide whistle stuff happening, got some growly stuff, and then have all sorts of interesting stuff in the middle that I can just start exploring. And I can start learning how to play this, right? I'm not even thinking about it, but I'm learning how this instrument feels to play. And so I'm practicing it as I'm exploring. If there's something that I don't like, right, if I don't like that sound, I can say, you know what, I'm going to map that to something else. I'm going to put that sound there, and I can keep retraining. And, you know, at some point, can save it, I can go perform with it, I can delete the whole thing and start over. All right, so that's continuous control. There's our tethered blowtar today. All right, so what does it all mean? What does it all mean? I have been using Wekinator for a while now. I made the first version in 2009. I've worked really closely with composers from the beginning and tried to understand why do they use it, right? There's lots of more cool-looking, robust pieces of software out there, but why do they use this? So I'll tell you a bit about that in a second. But first I'm going to show you some videos of some of my favorite pieces that people have made. So this first one is by a composer named Anne Heggie, and she's using the same golf controller, but to do something completely different. Just a little clip. So I like this piece because it's this really, both the movements and the sound are this calm, meditative, really warm kind of feeling, right? As a performer and as an audience member, she designed this to have this particular aesthetic and worked quite hard on it, and it's a beautiful piece. The next piece I want to show you is a clip of Letitia Sanami, who some of you might be familiar with her work. This is an excerpt from her 9 keynote last year, and the instrument that she's playing is called Spring Spire, and she's playing this wheel thing with 3 springs stretched across it, and actually using the audio from the springs as an input device. So you're not hearing the sound of the springs at all, but she's using that to sense how she's touching or plucking or scraping the springs. Oops, not the speed. Hold on. I want to draw the volume. There we go. Let's do this again. So I'm going to pause this there. This whole video is on YouTube, by the way. And again, this is a really interesting instrument, a unique instrument with really no attachment to performance practice on another instrument. But she's developed this way of playing it, and you can see it's very responsive to very subtle gestures. It's got a big sound space, yeah, it's interesting. It's fun to watch. Okay. In addition to working with these composers, I've been working with several other application areas. I've been working a bit with rehabilitation contexts. I can talk about that later on if you're interested. I've used it a lot with students. One of the nice things about this is that I can give it to students who may not be comfortable programmers, and they can still dig into interaction design and start making stuff. In fact, this is one of my favorite student pieces. Somebody trained his Python to play FM synthesis. This is called Snakeinator. And apparently he kept a Python in his dorm room. This is also on YouTube. I've also done some workshops with kids to try to get them excited about computing and music. And most recently, I've had a few projects building instruments for people with disabilities. So from all this, I'm going to close with just the lessons learned, the really high-level points about why this is interesting, why I'm still doing it something like 7 years later. So most clearly, when I ask people, why are you using this, especially professional composers with better things to do, the responses I get usually fall into a few categories. One of the things that ends up being really a clear theme in people's responses is that, well, it allows me to have a more satisfying design process. If you think about how fast it is to build an instrument, and then how fast it is to change that instrument and get something else, it's very quick. It's orders of magnitude shorter than programming, which means that people don't necessarily take less time to build instruments, but they try more things. They try more prototypes. They try out new risky ideas where they wouldn't spend 24 hours coding away at something, but they would spend 24 seconds. And sometimes that ends up being really exciting, and it turns out to be what they want. So again, you can look at literature and design in any field, and these activities of rapid prototyping, of hands-on evaluation, of the ability to iteratively improve something you've made. These are important, right? Machine learning can support this very nicely and arguably more effectively than code for certain types of activities. All right, and this is the case even for people who are expert programmers. Okay, the second point that I want to make is that here, when you're doing this process of building an instrument, creating a prototype, trying it out, the data is your user interface, right? Your data isn't this ground truth representing some phenomenon out in the world that you're trying to model. It's you telling the computer what to do, which is a different take on things, and it means that there are sometimes slightly different choices of algorithms that you might make compared to more traditional contexts. We can talk about that later. But data allows you to tell the system what you want, to fix mistakes, to explore these different alternatives. The next point that I want to make is that when people say, yeah, I use Wekinator, why did you use Wekinator? Well, one of the themes is it allows me to build things that feel right, or that feel better to use, or have this quality of physical engagement that I can't achieve when I'm writing code. And if you think about something like the string controller or Letitia Tsunami's springs, there's this physicality there, right? And it's easy for you as a person to say, I want to touch this spring like this or like this, and to demonstrate that, right? But it's going to be really hard for you to step back and say, well, what mathematical function might I design so that touching it like this is going to give me this sparkly sound? And so composers have repeatedly talked about, hey, this is something that allows me to think in terms of what most matters to me, gesture and sound, not math and code. And then finally, as a design tool, one of the exciting things that people have found when they're using machine learning for instrument building especially is they can be surprised, right? They can be surprised in the way that we were surprised when I was making this instrument, in that there are sounds that I get out of it that I didn't put into it. I'm not necessarily stuck with them. I can change them if I don't like them, but I wouldn't think to make those sounds. And every time I do this demo, I hear a sound that I've never heard before. So, in that sense, I guess this work has been really interesting for me, and I started out doing it coming from a more conventional machine learning background, thinking about machine learning as powerful because it makes accurate models and allows you to work with big data sets. And I've really changed my understanding of why it's exciting. This is a quote from Letitia Tsunami, who's a guest lecturer in my MOOC, by the way. I have a MOOC about machine learning for artists, which you should take. And the way that she approaches her work is that she wants this surprise. She wants complexity. She wants something that's going to really allow her to spend years and years developing this instrument and playing with it and still not be bored. And she says, you don't want the instrument to perform like a well-trained animal circus. You kind of want it to be a little wild. So she's got some nice stuff to say on this point. Okay, so my final claim here is that Yeah, programming is great. I love programming. I love teaching people to program, but it's not the only way to build things. And if we start thinking more broadly about machine learning and other practices as tools for creation, we're going to be better off. So with that, there's my MOOC. It's on Cadenze. We're going to be rerunning it in about a month. You can join for free. Please do. And if you want to download Wekinator, try it out. Go to wekinator.org. If you're looking for things to study, come study with us and do this stuff. And most recently, we are starting a human-centered machine learning online community. And if you go to this tiny URL and put your email address in, I will spam you when we have a Facebook group full of people who are interested in these types of things. All right, that's it. Thank you.